I wanted to kind of transition a little bit into what I would call designing with the course program and the relationship between programming and design, particularly at kind of the planning level. Because ultimately, coarse-grained programming is all about planning, being able to plan. And the planning decisions that you're making based upon coarse-grained program really are the broad strokes, the important kind of decisions about, for example, where should the site be, or is the site we're looking at going to work for the program? And there's also this thing called programming the site. You can program the building, but you also need to program the site. So we're going to shift the focus a little bit onto the site and the relationship between programming, design, and site planning and design. And so I thought I would use as a vehicle a project that I worked on that I've already mentioned in an earlier presentation. And that's the Ministry of Transport Training Institute, which was a pretty major project that I had the opportunity to spend a couple of years on. And so I'm going to, yeah, there we are. We got that dead spot. But this is, once again, just explains what the Ministry of Transport Training Institute was. It was a project that started in 1971 and ran for about 3 or 4 years in total. And it was to consolidate all of the training of technology, technical personnel of the Ministry of Transport, which included air traffic controllers, marine pilots, radio operators in the Arctic, a whole range of people who were involved in technical support, including computer programmers and so on, for the Ministry of Transport. So what we did, and I was the leader of the programming team, was we put together a very not comprehensive program, but we first of all put together a coarse-grained program, which was all about developing site selection criteria, developing what the larger sort of components of the facility would be in terms of what departments are going to be there, what's the type of facility they need. We did, without narrowing it down to sort of the details or the fine grain. We weren't getting too involved at this stage in what happens inside the rooms, or even how many rooms there are. It was really more about how many components or sections or divisions there would be. We did eventually do a fine grain program, but this was a sort of a back and forth operation where we, first of all, we did a survey across the entire country, of the various people involved in technical training. And then based upon that, we put together an operational program, which was all about how should this school operate? Should it all be in one location, or should there be 2 or 3 locations? And where should those locations be? And based on our study, we determined that it should be in one location, and that it should be in the area where there's the largest density of population in Canada, which happened to be in Ontario, right sort of between Ottawa, the capital of Ontario, Montreal, and Toronto. The Toronto, Montreal being by far the largest cities in the country. So that's where the largest population was, and it was the most convenient for folks to get there and spend time there. And this was a training facility where they would spend 1 to 5 weeks being trained in upgrading their skills and knowledge. So this is kind of a summary of where we ended up. We ended up with a complex of buildings, 628,000 gross square feet. So this was a pretty big building, and it was located on 72 acres. We had several sites that we were candidates, and it was narrowed down to this one site in Cornwall, Ontario. Cornwall, Ontario is a relatively small town, on the St. Lawrence Seaway between Montreal and Toronto, approximately halfway between. Um, and I'm not going to go through this. Obviously, we can't see part of it, but we'll get into it with the diagrams. Yeah.
How did since you said it was a small town, how did the town feel about this huge facility with all these people coming into it?
Actually, they were pretty happy because it was a source. The town really didn't have much going for it, other than there was sort of a minor tourist industry. And so this was a source of jobs and income for local businesses, and it was certainly going to be a good source of tax revenue for the city, for the town. So they were very much on board, because this wasn't a place where people would be coming and going and lots of traffic or anything, because they would arrive and stay there for maybe 4 or 5 weeks. So it turned out to be welcome by that community. But there were some real issues, and I'm going to get into in a second. So it was what it says here, from Ottawa, again, the capital of Canada. There was a direct highway route from Ottawa, and Highway 401, which is the main sort of east-west expressway in Ontario. It was right on that highway. So here's a map. Here's the site over here. Highway 401, the main sort of Trans-Canada highway, which is sort of like I-10. There's St. Lawrence Seaway down here. The main part of the town is over here. And this is sort of one of the suburbs next to the town. But you can see how small the town is. It's sort of like Quincy or something like that. So the roads, there was pretty good access to this. There's this road here, which when you come off the highway, you can come in through the center of town and then come down these streets here to get to the site. This road here was sort of almost a dirt road, not a very, it's like a 2-lane road. So when we were programming the site, and what I mean by programming the site is collecting all of the information, and we sometimes, parts of this might look a lot like site analysis, and it is really, in a sense, site analysis. The initial part of this exercise was site analysis. So we started to look at things like the dimensions of the site, which you can't really see, but there's sort of each one of the boundaries has the dimension. And over here is a sewage treatment plant next to the site. And over here is a elderly housing, elderly facility that was a progressive care elderly facility for people who went from active independent living to nursing care next to the site. This was a farm. Originally, here were the barns, stone farmhouse, a wood frame farmhouse, and then these were sort of the fields, and these are windbreaks. Particularly out in the prairies, when you see trees like that in a farm, that's to shelter this area from the wind. So again, this is how, and I really wish this wasn't wiped out, but these were the various ways that you could approach the site. The main one being along here, Montreal Road, which is called Montreal Road because it goes to Montreal in this direction, And in this direction, if you were to continue going along the St. Lawrence River, you'd end up in Toronto. But it's really not a practical way to go. You really are better off going up to the expressway. The slope, the topography, the river's here with a very, very steep slope right here. And then it flattens out, and there's some sort of some gullies here. And of course, we went through all the normal things like looking at wind directions and sun angles and so on. We had to worry a lot about snow. This is in the snow belt. There's lake effect snow. And you probably hear about Buffalo and Syracuse and those places getting lots and lots of snow. Well, the same thing happens on the north side, Lake Ontario and St. Lawrence. So you get 4 to 5 feet of snow. Now that doesn't all happen in one time, but it can. And there's a fairly constant breeze. I have to call it a breeze, 6 to 13 miles an hour. But what it does when it's snowing, it causes snow drifts. And that's when you get into trouble, because even though you may have only had a foot of snowfall, with enough wind, you end up with snow drifts 4 or 5 feet high, depending on the terrain and topography and so on. And the other thing that happens is the snow plows go down the street and they pile up the snow on the sides of the street. Sometimes you can't find your car. Believe me, I've lived that. So this was sort of that, as I said, that transition phase between programming and design. And one of the first things that happened was we sat around the table with the design architects, Ron Tom and Associates, and my team, and we went through the program and discussed it in kind of general terms, or in sort of large brushstrokes. What is this place really going to be? What's it going to be like? What are the major parts of it? What's the most important thing to pay attention to? That kind of discussion, which you can't really get by just reading the document. You have to have that sort of exchange. And it was based upon that understanding that we began to work with the architect on developing actually the design. But this was the rational sort of step-by-step process that I'm going to show you now that was used. And it's not necessarily one I recommend, because it's sort of like taking programming and directly making it into the building without some sort of intervening major input by the design architect that's, you might consider, creative and outside the box thinking. So one of the first things we did was we looked at how big is the building footprint, how big are the various components of the program in relationship to the size of the site. So in this diagram, what we're doing is we're showing the total building area. So the bigger box is the net programmed area, the usable space, and then this is the gross area, or the additional space taken up by mechanical, wall thickness, and things like that, stairs. And then if you break it down into the 3 main components of the program, there's the teaching areas. Just remember, this is a residential training facility. There's the residential part, and then there's all the common support areas. And this is all sort of the building program components. Then there's also, we looked at also what happens if you take that building footprint and you put it on more than one level. For example, if you do 3 floors of the teaching areas, it becomes this big in relationship to the site. And if you do the residential on 3 floors, and if you do the common areas on 1 floor, which seemed reasonable to have the common areas. Common areas were things like cafeterias, gymnasiums, and so on. So we're beginning to see how big the site is in relationship to the program. Now, there was a significant component of this program that was not in the building but was outside. Part of that is the recreational component. You can't see it very well here, but these are all the different playing fields. Like this is a football and soccer, ice hockey, tennis, baseball, softball, and so on. Those were things that needed to be there. Oh, and this is parking down here. So that's one type of demand on the site. But the most important and the biggest demand and the most difficult, and the reason we're even going through this exercise, this program and the site exercise, is because of all the electronic and meteorological field installations that had to be there for training purposes. So they were trying to simulate an airport, for example. So here they are. And these are different radars. This is a VOR, Visual Orientation Radars. This is a meteorological observing compound for weather studies. These are instrument landing radars for air traffic control. And these are other types of radars and things that have to be outside. So if you just glance at the playing fields that are needed, the radar installations that are needed, and remember what the building footprint needs, we started to become very concerned because this almost fills up the entire site. The other thing we had to worry about, and it's shown over here, constraints on locating the electronic field installations. People with pacemakers over here. Everybody here probably has a pacemaker. And these radars had large fields, electronic fields, from the power lines going to the radars and back into the instruments in the building. So there was the Department of Health, OSHA, Ontario Health Department, said that we had to be 1,000 feet away from anywhere where these elderly people with pacemakers would be wandering. And some of them had Alzheimer's, so they might even, be back in the corner. So now we've got only this part of the site where we can actually put electronic instruments that had high voltage facilities. This is where the actual heavy teaching labs were most suitable, and this is field installations could be back here, depending on how the cabling is running. We also began to work with the technicians in figuring out what overlaps could occur in these field installations, because we realized that it's just not going to work if we didn't do something like that. So it was determined that these two radars could overlap here. The weather monitoring facilities could overlap with this radar, and so on. So there was some efficiency that we could achieve by doing that. So that created that outline for the radar installations, for the field installations. And then it became an exercise in trying to figure out what's the best place to put that kills fewer of the elderly people, that is not in the middle of the sewage plant. So we tucked it over there, we tucked it up here. Then we realized we better get it as far away from this corner, so we sort of stuck it way back, as far back as we could, over here. So this became the location, and we had to, and there was a certain distance that the actual equipment the teaching labs had to be from, they had to be a certain, they couldn't be too far away from the field installations. So then we switched over and started looking at the building again. And the teaching areas, we also looked at how can we cluster them and how can we nest them in different ways, because we were tight on the site. The site was a real challenge. And there had been a commitment to that site. And at this point, we were still questioning whether we shouldn't try, the government shouldn't try to get out of that commitment. So this was one way of moving the components around. This was another way. Just conceptually, how do you begin to work with the major programming elements in this course grain program? We also looked at what happens with future expansion, because in addition to the program that we developed, there was always this issue of the facility needing to expand in the future, and that was in the program, and it was a major part of the considerations in the course grain program was what areas needed to expand and how much accommodation should be made in the design for that expansion to occur. So this one shows each department. These are just examples of departments would expand in a similar way. This one doesn't expand. This one here, which was the most promising, allowed certain departments to expand in two directions, other departments to only expand in one direction, and so on. So this, it's very conceptual. So these are other expansion possibilities, a more complex clustering with a variety of expansions, or this one where you just add a new department. So interestingly, at this point, the architects at the table said, well, in order to make any of this, to provide any kind of order here, why don't we develop a grid, a structural concept that can then begin to organize all of these possibilities, because otherwise we weren't going to get anywhere. So they decided that that would be the thing that would be the starting point, a structural module or a system of structural modules that would then we would try to work within that to fit the program into it. So this is what they came up with, a uniform structural grid. And this was an interesting way to approach it, because then what they did is they selected certain areas within the grid and said, designated, that's a mechanical node, that's a mechanical node, that's mechanical. So they looked at servant and serve. Like, what can we begin to establish as servant pieces within the grid that could then feed into the served areas? And mechanical was one of them. And so they investigated the idea of those being along one side. They also looked at what happens if you distribute the mechanical nodes. These are the service nodes sort of throughout. Or you evenly distribute fewer service nodes. And the next part of that was all of the circulation systems that would maybe provide another ordering system. Because we're looking at ordering systems coming not from the program space, but the serve area, the serving areas that serves the program space. So the circulation system pattern, conceptually, that we came up with was a major spine, and then sort of north-south, and then minor movement, and then applied it to the grid. So you get sort of movement in this direction, and then within that would be smaller arterial movement systems. And so then, okay, let's see what happens if we kind of rough in the gross sort of rough programmed areas, and they began to sort of fit in to this infrastructure, to this system. And then, then we looked at the mechanical nodes and how the distribution patterns work within that. And the outside configuration of this was simply nesting all of the programmed areas in without worrying about the configuration of the building as a whole, but worrying about how it functioned as internally in terms of movement and so on. So that really became the starting point for kind of the conceptual direction for the building. Then there was the residential component, which was also a pretty important piece of the puzzle. And so the decision was made to break the residential component down into small pieces. And we actually consulted a social psychologist on this who was well known for thinking about how large a group provides the optimum amount of social interaction within a residential component. So what is too many bedrooms and what is too few bedrooms to create the kind of positive interaction, because these people didn't know each other when they arrive on site and they're only there for a relatively short time. So we wanted that to be an aspect of the thing. And it was determined that a group of 8 rooms was ideal, and they would share a living room and share certain facilities. And also we looked at what could you have in terms of vertical relationships and vertical circulation, and it turned out that 4 levels seemed to be optimum. We didn't want to get up too high, but we had to, because of the site constraints we had with the size of the site, we had to be fairly efficient with that. So there was a whole exercise where we looked at corridor patterns and where people would meet informally and accidentally and get to know each other, so that there was a group feeling of group cohesion, and so people were socializing. So we interconnected things. It wasn't a simple thing. It was a fairly complex pattern of interconnections in corridors and stairwells and things like that. And there were social areas that were within the family being 8 rooms. And then there were a cluster of 16. There was another sort of group area, and then there was a group area for the whole house. So now we looked at, again, conceptually, this would be the residential area with this clustering, the common area, and the training area, the teaching area, and the common area being between. And one of the concepts here was that, and this came out in the programming, was that we didn't want people living and learning in the same building. We wanted there to be a journey to work. We wanted people to feel like they were getting away from the classroom when they got to the residential part. So they got some relief from that. And so the circulation went through the common areas. So these were the kinds of things that were provided in the common area. There was a bank. There were teller machines. Automatic teller machines were a brand new thing then. They had just been invented. The ATMs, barbershop, cafeteria, laundromat, tuck shop, which is like a 7-Eleven thing. Sports facilities. A clinic with a nurse and so on, counseling services, parking, shuttle services to the airports and so on. Those are the kinds of services that were In looking at the residential component, we really wanted to take advantage of the river. Because it's a beautiful river, and with the slope, there was a fantastic view. So it was decided to place the residential on the hill, which worked okay because it was a series of small pieces rather than one big building, and it could kind of march down the hill and take advantage of the view. And also, the south exposure was great because this is Canada. In the wintertime in particular, you want as much sun and warmth coming in as you can get. And we had to look at growth and expansion. What you can't see here is there is a deliberate effort to design this so that if they needed to add, the wings could grow in this direction, add more rooms. And the circulation, again. Then we switched from the residential to the training building and looked at ways that you could configure that. In this case, having 3 wings with a shared sort of node. In this case, running the building north-south and putting it in relationship to this so that this becomes the common area. Another option here, moving it further down the site, closer to the river, closer to the road. You don't even really see the road because of the slope. If you're up here, you're more conscious of the river and the view of the water. And so the final decision was to run the training building east-west and put the service support common areas in the middle like this. And again, the expansion was a concern, so the building could expand in this direction to the north. The residents could expand to the south. And again, in the program, it talked about courtyards and social, informal social interaction in the common areas and so on. And that's what this is showing, having the common areas kind of working around the courtyard space. Circulation, how do you get from here to here, all the different options. We want there to be alternatives. You could skirt around the outside and avoid people in there if you're feeling antisocial, or you could walk through and interact with people that you see there. We also had to think about where the main entrance was and how do people approach and what's that like. And it was decided that this side of the building here, the west side, would be where the main entrance would be. It could have just as easily been over here, but this is the sewage plant. And it did have a slight bit of an odor and so on. So we found it was better to come in next to the facility for the elderly and come in this way. So again, this is the expansion. I think I already looked at that. Landscaping, we wanted landscaping, again, it was in the program. Landscaping was critical and important to give people a more pleasant place to be away from home here. So we concentrated on landscaping sort of in this area because remember, we needed all of this for all the other things like the parking and all the radars and the playing fields and so on. In addition to where you enter, where the public and the students who are coming to this training, where they would enter, we all had to worry a lot about service vehicles. There was a lot of service components. So the service, remember the entrance is over here, so the service is back here. So this is looking at what services were available on the site and what services need to be added to run this place, like gas lines, electric lines, sewer lines, water, and so on. Fire hydrants. These are the fire hydrant locations. some of it was existing, some of it had to be added. So the roads, you can kind of, well, you can see it better here. This became the road pattern, where you come in the main entrance here. If you're providing service, if you're a service vehicle, you go off to the right. If you're a visitor or someone staying there, you go off to the left. And there's a loop here, and there's a parking lot here, and you come in the entrance, or you can park here. You can also come in the back door, but that's not preferred. The idea is that there would be a main gate, main entrance. And these other entrances were there for convenience and in case you needed to evacuate the site. The playing fields became a challenge because they sort of received third priority after the radars and the buildings. So they had to be put wherever we could fit them in. So they ended up being kind of piecemeal located in different locations, like over here. And these are the radars, and here's the residential, the training, parking. So these were the kinds of things that we incorporated. There was a 25-meter swimming pool, a double gymnasium, weight rooms, fitness, exercise rooms, saunas, whirlpools, ping pong tables, billiard rooms, and so on. Those were the indoor facilities in the community center. The outdoor, there was softball, diamond, tennis courts, horseshoe pits. Remember, these are rural Canadians. You know, they're the Canadian version of rednecks. Access to community-wide bicycle paths and soccer fields. No lacrosse. No. So nearby there were golf courses and other kind of racquetball, curling rinks. Curling, big sport there.
Sweet yes.
So I just thought I'd show you some images of the building that was designed. And you can see it's a building that looks like it was designed from a functionalist perspective using a program. Because every sort of element of the program is revealed in a straightforward and logical and rational, sort of clean, modernist way. Like stairwells, and you know, you can tell, almost tell what different things are by that. And this is the interior main circulation route. Remember that there was that east-west main circulation, and then down here, which you can't see at all, is sort of one of the cafeteria lounge areas. So this feels very much like a mall, and that was intentional. One of the interesting things about this was they ended up using heat pumps, and there were over 100 heat pumps in the building to individually control all the labs, because they had such critical requirements, and throughout the building there was such a variety of demands, needs that were needed in the different labs. In those days we had computers that were large. You probably saw, like in 2001 Space Odyssey or something, large banks of computers that would fill a room like this, with just computers that were throwing out a whole bunch of heat and needed to be cooled constantly. So there was very high cooling demand on some parts of the building. Other parts of the building at the same time required heating because it was in the wintertime and so on. So a lot of the system was designed to be as flexible and as efficient as possible. So we didn't go to any centralized systems. It's all decentralized. The other thing that was interesting, and we got into a lot of trouble over this, was that we had the the power line running from the radar lab, from the air traffic control simulators, where they would learn how to, bring airplanes in to land at airports. There was heavy wire, big electrical cables running from that lab over to the radars, and they ran right underneath the computer lab. And that caused all kinds of problems for the computers. The electronic field was given off. It was so strong that it was causing problems for the computers. So we had to, after we had moved everything in, and we were involved in moving in all the equipment and getting it tested and everything. We had to move an entire operation out because of the problems with the power fields. So even after, with all the careful planning and programming and thinking and development, and with the big team of engineers and architects and laboratory specialists and everybody else, we missed that aspect of the project. So I think that's the last. Yeah. So what we were really doing here, I regard as, it's site analysis, it's master planning, it's programming the site in a funny kind of way where we're looking at reconciling the coarse grain program with the opportunities of the site, and maybe even going back and cycling back to the program and making adjustments to the program, and then making adjustments to the way we handle the site. Issues came up like, can we overlap the radars? And that wasn't in the program, so then we had to go and reprogram that section of the program to really uncover to what degree can those radars be overlapped so we can have a more efficient footprint on the site. So it was kind of an example of programming and design, kind of looping through as we went along. So that is the last slide. Okay, does anybody have any questions or comments?
When was it constructed again?
1975, 76. Anybody?
When you moved out that whole operation because the oversight that you overlooked the electromagnetic field from the high voltage lines,
Yeah.
did they ever reroute those lines to make that room functional
that
again?
was just not practical. They tried shielding them first, and it just didn't do the job. No, they were so tied in to the building, and they were so integral to the whole layout of the whole thing. It was much easier to move the computers than to move the simulation. Because the simulation room was specially designed to be an aircraft, an air traffic control simulation facility. It sort of looked like NASA. You see those in the NASA control room where you get all these. And of course, the simulators back then were not as sophisticated as the ones we have now. They were sort of like video games where you sit down and you've got the control panel and everything. You've got a screen in there, and you're learning how to. I don't know if you guys have ever been in an air traffic control tower, but what they do seems to me really old-fashioned and fraught with problems, where they're moving these little pieces of paper over from here to here, and it just didn't seem right. But they have learning how to do that and doing it well. Obviously, it's critical. Did anybody see the movie with Billy Bob Thornton, where they were air traffic controllers?
Yeah.
Yeah.
Well, that's sort of.
Pushing 10, yeah.
He was working for NASA.
No, he was air traffic controller. I forget what the
Pushing
other-
10.
Pushing 10, that's it.
They come up with Armageddon.
No, pushing 10. Yeah.
that. Yeah, I saw your question. You know, I was gonna tell you in person.